Our next topic, graphs of asymptotic notations. In order to understand asymptotic notations visually, so let us use notations. First, look at a graph of big O notation. This is the one. We draw f of a function first. Okay? So the lower curve, suppose that is f of n function. Now, we want to use some upper bound for f of n. We want to use some upper bound to measure it. So what kind of upper bound we want to use? Here, in this situation, f of n belongs to big O of g of n. We use the constant, positive constant c positive, positive constant multiple of g of n as some upper bound. So we can find some positive constant c, c positive, all right? So make sure this little c is positive, okay? That's the first one. Second, big omega notation. So here, let me explain. We have little omega, right? Little omega. The limit of f of n over g of n equals infinity. That's little omega. But similar to our big O case, we have some big O omega notation. So what is the big O omega? Definition of big O omega. For a given function g of n, the notation big omega of g of n represents the set of functions f of n that satisfy the following condition. Inequality. There exists some positive constant c and some non-negative integer n0. You can see environment setup the same as before. The difference is first this inequality. F of n has a lower bound. This is a lower bound. What kind of lower bound? Positive constant c multiple of g of n function. That is the lower bound form. And little o when n greater or equal to little n0. When that is true, we have that big omega notation. Okay? So that is the meaning. So you can see you can put all these things together. Upper bound, big O notation, lower bound, big omega notation. Okay? For the graph, we can draw the similar graph. This time, constant multiple, positive constant multiple of g of n is used as one of its lower bound. We may have many lower bounds, right? You can draw many lower bounds. So this one is one of its lower bounds. That's enough. That's enough. Okay? And this line, n0 line, doesn't matter. That means this part, n less than n0, that part doesn't matter. Doesn't matter. Why doesn't matter? Let me repeat another time. Overhead occur here. That's why it doesn't matter. Okay? We want to skip the overhead part. Okay? All right. Big theta notation. Big theta. This time, think about, we have upper bound, we have lower bound. How about we put both upper bound, lower bound together, right? Big theta. Upper bound, lower bound together. So this time, we repeat the same language related to the environment, but we need to use two constant, C1, C2, two constant. So this time, lower bound C2 g of n, upper bound C1 g of n, and n0, sufficiently large condition. Okay, yeah. So now you can see, yeah. At this point, we have total 5 asymptotic notations. This big theta we used before. In our limit case, we use it, right? Think about limit case. We have the limit of the ratio equals non-zero constant C. That corresponds to big theta. So here, we describe it in upper bound, lower bound way. So we describe big theta notation 2 places. Limit language, inequality language, 2 different ways for big theta notation. So total, here at this point, 5 asymptotic notations. Yeah. All right. Yeah. Any question at this point? Yeah. All right. Yeah. The graph, yeah, straightforward, right? For the upper bound, lower bound. Yeah. So pretty straightforward. Yeah.